All right, let's dive into something that honestly sounds like it's straight out of a science fiction movie, but I promise you it's very, very real. We're talking about Windows Server 2025, where Microsoft is basically re-engineering Hyper-V networking for speeds that are going to completely change the game in the data center.
Just look at that number, 800 gigabits per second. Let that sink in for a minute. That is a truly mind-boggling amount of bandwidth. So you gotta ask, what in the world could possibly need that kind of speed? And how is that even possible?
Well, the answer isn't just about going faster for the fun of it. It's actually become a necessity. You could almost call it a survival tactic. See, the kinds of workloads we're all running today are so incredibly intense, they are pushing our current infrastructure to its absolute breaking point.
And here are the main drivers behind this revolution. We're talking about training huge artificial intelligence models that just chew through petabytes of data. We're talking about massive scale databases that are handling thousands upon thousands of queries every single second. And on top of that, we have this whole new wave of data-heavy workloads that we're only just beginning to dream up. These things are demanding a total rethink of how we do networking.
Okay, so that's the why. We get it, the demand is huge. But now for the really cool part, the how. How in the world does Windows Server 2025 actually pull this off? Because this is where the engineering gets absolutely brilliant.
It all starts with the foundation. They didn't just put a patch on the old system, they threw out the old blueprints and designed the whole networking stack from the ground up. It's been purpose-built for one thing, to handle the absolute fire hose of data that's going to come from these new 800 gigabit per second network cards.
And one of the secret weapons making this possible is a technology called Software Delegated RDMA. Now that's a mouthful, I know. RDMA stands for Remote Direct Memory Access, but here's the easy way to think about it. It's like a dedicated high-speed HOV lane just for your data. Instead of getting stuck in traffic on the CPU, data from your virtual machine can just zip directly to the storage. It's not only way faster, but it's also more secure.
And the difference this makes is, well, it's not subtle, it's dramatic. The old way of doing networking absolutely hammered the CPU. But with RDMA taking over, that load just plummets. And this is the key takeaway. You're not just getting faster networking, you're actually freeing up your expensive CPUs to do the real work you bought them for, to actually run your applications. Now you might be thinking, all this power must be incredibly complex to manage, right? Well, that's where Microsoft is something really smart. They built what is essentially a co-pilot for your network to handle all that complexity for you.
It's called Network ATC, which stands for Automatic Traffic Classification. Its entire reason for being is to get rid of that tedious, error-prone nightmare of configuring networks by hand. So no more late nights trying to get VLANs, MTU sizes, and teaming settings just right.
And the process itself is just beautiful in its simplicity. First, you just declare your intent. You tell it, hey, this adapter is for storage. That's it. Then Network ATC goes and inventories all of your physical hardware. And finally, it just configures everything automatically, deploying the absolute best settings for that specific job. It's a huge time saver, and it slashes the risk of human error.
So instead of getting lost in the weeds, you just think in terms of roles. You can say, okay, this network is for management, this one is for compute, and this one over here is for high-speed storage. You give it those simple instructions, and Network ATC handles all the messy, complex details underneath.
But it's not all just about speed and automation. They also made the virtual switch itself a whole lot smarter and safer, which is a huge deal for anyone running complex setups like cloud services or multi-tenant environments.
Take software-defined networking, or SDN, for example. In the past, setting this up was a massive project. It required all this complex external gateway hardware. The new way? Windows Server 2025 just includes a simple, high-performance native gateway right out of the box.
And the benefits are exactly what you'd hope for. Deployment is so much simpler, the performance is better, and it's perfect for anyone who needs to securely separate traffic, like hosting providers or large companies with different departments.
On top of all that, they've also improved something called switch-embedded teaming. Now, what that technical phrase really means for you is just more reliable load balancing and failover. The bottom line is simple. More uptime and rock-solid consistent performance for all your virtual machines. Okay, so we've seen all these incredibly powerful new features. So what's the blueprint? How do you actually put all this to work and get that amazing top-tier performance?
Now listen up, because this is probably the single most important piece of advice you're going to get. To truly unlock the full potential of Server 2025, you have to start with the right hardware. Your physical network cards must support RDMA. We already know why that's a game changer, and they also need to support something called RSS, or Receive Side Scaling. RSS is key because it helps spread the network processing load across multiple CPU cores, preventing any one core from getting overloaded and becoming a bottleneck.
And that really brings us to the core philosophy behind every single one of these changes. If you remember one thing, make it this. Server 2025 is built to take the network processing work off of the main CPU and push it onto the specialized network card where it belongs. This frees up your whole system to do what it does best: run your applications.
And that leads us to the final thought. These software advancements are absolutely incredible, but they all depend on the hardware that's running underneath. So as we all step into this new 800 gigabit era of networking, the real question you have to ask is your hardware ready for it?